This movie was recorded using a new unsteady state black oil wellbore simulator, USWS. It's intended to calculate the flow of oil, water, and gas in the pipe segments of a vertical or horizontal well. In this movie, we will show the capability of the program to model a gas bubble rising in a static water column. It will show the countercurrent flow capability of the multiphase calculations. We will use a 3,000 feet vertical 4-inch tubing subdivided into 30 segments. We will initialize the lowest segment as a gas segment and all upper segments as water filled. We will run this as a closed system with no production, injection, or reservoir flow. We will watch the gas rising up the well as it is lighter than water. We will show the pressure, water, and gas saturations and rates in the wellbore segments. This is the user interface of the unsteady state wellbore simulator, and we will review the results of the run. So we open up the file that's been run previously, and we will show in here, we pick up the pipe tubing 4.5-inch OD, 4-inch ID, and we will show the parameters of pressure, water, gas saturation, water rate flowing into the pipes, gas rate flowing in the pipes at all times. These are our output times in the simulation. And we're going to report for each time the pipes and the parameters. And we will click on the report. And we can see here that we have multiple segments. We have the time, current time, 0 days, the pipe number, the segment pressure. This is the calculated pressures of the well segments, the segment saturation, and it goes 29 water filled segments, 1 gas filled segment, and conversely for gas saturation, no gas in the first 29 vertical segments and gas at the bottom segment. And then we will step through time. We go through next time, and we'll start to see movements of gas, water saturation, pressure changing, flow rates going in the well. And if we display the current wellbore schematic, and we will show, for example, the water saturation, you can see that this is 0 here for the bottom and 100% water in all the rest of the pipes. Display the next parameter, the gas saturation, and we can see that, and if you display that as a aspect ratio. Now if we animate next time you can see the gas saturations going up the well, rising up, going up with time, changing with time, until we accumulate the gas at the top of the well, and that is accumulating at the top of the well without data change. So if you look at the table of values, we can see the same thing happening in the table of values. We can see that the gas is rising up, the slug gas rising up, multiple bubbles essentially, rising up, and accumulating at the top. And we originally had 1 segment at the bottom. Now we have 1 segment at the top and a little bit more due to gas expansion at the lower wellhead pressure than the original initialized pressure at the bottom of the well. So there's a gas expansion as well. So we have recovered all our gas at the top of the well is accumulated of the well. We can also see this effect in the 10 segment case, where we have initialized 10 segments at the bottom of the well, 10 segments at the bottom of the well, water and gas. So if we display the well ball, look at our water and gas schematic, and if we go through with time again, with time we can see that the water is falling down, the gas is rising up, displacing the water, displacing the gas, rising up, and eventually we have a gas accumulation at the top of the well. And you can see this again with the tables, numbers. See tables and numbers, we can see the gas saturation, we can see the water saturation, you can see the rates of fluids, negative flowing out to, going downwards, positive flowing upwards in the same pipe. This over a very small period of time, very small time steps, and we can see the accumulation of the gas at the top of the well, until it gets about 10 columns of gas, equivalent to our 10 segments of gas at the bottom, with some expansion due to lower final pressure than the original pressure of the gas. So this shows the capability of the unsteady state wellbore simulator to segregate in a countercurrent flow manner the gas and water in the pipe. This is useful for simulating gas-water loading systems. Thank you for your attention.